AI Knowledge is Power presents AI in 10 minutes. The video every future-proof professional needs to watch. Artificial intelligence. You hear these words everywhere now. It sounds like science fiction, perhaps from a distant galaxy. But AI is not just a futuristic dream anymore, folks. It is here, right now, reshaping our very world. It's a powerful force, a new kind of cosmic tool. Understanding AI is becoming absolutely essential for everyone. It is the key to navigating the immense changes ahead. Your career, your future, might just depend on it. Think of AI as a truly transformative wave. Consider it like the discovery of electricity was, or perhaps like the invention of the printing press. These innovations changed everything about human life and society. AI promises to do the same, and maybe even more. It is fundamentally altering how we work, how we live. It even affects how we connect with each other daily. Future-proofing your career means embracing this profound change. Many professions are already feeling AI's significant impact. This spans from doctors to artists, from engineers to writers. Let's explore together what AI truly is and what it can do. So what is this thing we call artificial intelligence? It's not just about walking, talking robots from movies. That's a common image, but AI is much broader. It's a branch of computer science, a very dynamic one. AI aims to create machines that can perform tasks that typically require human intelligence to complete. Think about learning, problem-solving, and decision-making. Essentially, it's about making computers think or act intelligently. The fundamental capabilities of AI are quite diverse. These include the ability to process vast amounts of data. AI can recognize patterns that humans might easily miss. It can make predictions based on those identified patterns. AI systems can also understand human language to some extent. They can perceive the visual world around them, like we do. And crucially, they can learn from experience to improve. This learning aspect is what makes AI so powerful. Consider the tasks you perform using your own intelligence. You read, you understand, you make choices, you learn new things. AI research tries to replicate these abilities in machines. This could be as simple as a spam filter in your email, or it could be as complex as a self-driving car. The goal is to build systems that augment human capacity. When we talk about AI, it's not all one thing. Scientists often divide AI into two main categories. These are artificial narrow intelligence, or ANI, and artificial general intelligence, often called AGI. Understanding this distinction is crucial, folks. It helps us separate today's reality from future speculation. Most AI you encounter today is actually ANI. It's specialized, like a focused laser beam. Artificial narrow intelligence is designed for specific tasks. Think of your smartphone's voice assistant, like Siri or Alexa. It's great at answering questions or setting timers, but you can't ask it to write a symphony for you, or to discover a new law of physics, for instance. Spam filters, recommendation engines, and game-playing AIs are ANI. They excel in their one well-defined domain. They operate within pre-programmed constraints and datasets. Artificial general intelligence, or AGI, is different. This is the type of AI you often see in movies. It's an AI with human-like cognitive abilities across many areas. The truth is, we are not there yet with AGI. Now, how do these AI systems get so smart? A big part of the answer is machine learning, or MML. Machine learning is a subfield of artificial intelligence. It's the engine that powers many AI applications today. Instead of explicitly programming a computer for every task, we use ML to allow systems to learn from data. The machine literally teaches itself, based on experience. It finds patterns and improves its performance over time. There are three main ways machines learn, broadly speaking. The first is called supervised learning. Imagine a student. You show the student examples with correct answers, like flashcards with cat pictures labeled cat. The machine learns to map inputs to outputs. It sees lots of labeled data, like spam or not spam emails. Eventually, it can predict the label for new unseen data. This is great for classification and regression tasks. The second method is unsupervised learning. Here, the machine gets data without any labels. No teacher, no correct answers are provided initially. The AI's job is to find hidden structures in the data. It might group similar items together, a process called clustering. Or it might find unusual data points, called anomaly detection. Think of it like exploring a new planet without a map. The AI discovers patterns and relationships on its own. Section 5. Deep Learning AI's Neural Networks Get Inspired. Within machine learning, there's a particularly powerful technique. It's called deep learning, and it has fueled recent AI breakthroughs. You might have heard about neural networks. Deep learning uses artificial neural networks with many layers. These layers are deep, hence the name deep learning. These networks are inspired by the structure of the human brain, though it's a simplified model, not a perfect replica. But the inspiration comes from our own complex biology. What makes deep learning so special is its ability. It can automatically learn features from raw data. In traditional ML, experts often had to handcraft features. This was a time-consuming and difficult process. Deep learning models given enough data can bypass this. They learn hierarchical representations of the data. Lower layers learn simple features like edges in an image. Higher layers combine these into more complex concepts. Think of how a child learns to recognize a cat. First, they see lines, shapes, textures, and colors. Then they learn to combine these into fur, ears, tail. Finally, they recognize the whole concept of cat. Deep learning models work in a somewhat analogous way. This ability has led to huge advances in many areas. Section 6. AI's senses, chatting, and seeing the universe. So AI can learn, but how does it interact with our world? Two key areas of AI give machines senses. These are natural language processing, or NLP, and computer vision, which deals with visual information. NLP allows computers to understand and generate human language. This is how your voice assistant understands your commands. It's how translation apps can convert Spanish to English. It's about bridging the gap between human and machine communication. Natural language processing has many applications. Think of chatbots that provide customer service online, or sentiment analysis tools that gauge public opinion. These tools scan social media posts or product reviews. NLP also powers spam filters by understanding email content, and it helps search engines understand your queries better. The goal is to make human-computer interaction more natural, more like talking to another person, less like coding. Then there's computer vision, AI's way of seeing. This field enables machines to interpret and understand images, and also videos, just like our eyes and brain do. It involves tasks like object detection in a picture, identifying faces in a crowd, or recognizing handwriting. Section 7. Echoes of the future AI's journey through time. The idea of artificial intelligence isn't brand new. It didn't just pop up with the latest smartphone. The dream of creating thinking machines is ancient, found in myths and stories from long ago. But the scientific journey of AI has a more recent start. Many trace its modern beginnings to the mid-20th century. A pivotal figure was the brilliant Alan Turing, a British mathematician and computer science pioneer. In 1950, Turing published a landmark paper. He proposed what is now known as the Turing test. This was a test of a machine's ability to exhibit intelligence indistinguishable from that of a human. He asked, "Can machines think?" A profound question. This work laid some of the philosophical groundwork for AI. A few years later, in 1956, the term artificial intelligence was coined. This happened at the Dartmouth Workshop, a key event. The early years of AI were full of optimism. Researchers made exciting progress in problem-solving and logic. They developed programs that could play checkers. They developed programs that could prove theorems. But then came periods known as AI winters. Progress slowed, funding dried up, and hype faded. Section 8. AI Today, Remaking Our World, One Algorithm at a Time. So, where is all this AI technology being used now? It's not just in research labs or science fiction. AI is already impacting many industries right now, transforming how businesses operate and services are delivered. Let's look at a few critical sectors. Healthcare is one area seeing profound changes. AI helps doctors diagnose diseases earlier and more accurately. It analyzes medical images like X-rays and MRIs. In finance, AI is also a major player. Algorithms are used for fraud detection in transactions. They can spot unusual patterns indicating illegal activity. AI powers high-frequency trading on stock markets. It helps in credit scoring and risk assessment. Personalized financial advice through robo-advisors is another use. These systems manage investments based on your goals. The goal is often efficiency, accuracy, and security. Transportation is another industry undergoing an AI revolution. The most visible example is the development of self-driving cars. These vehicles use AI to perceive their environment. They navigate roads and make driving decisions. AI also optimizes logistics and supply chains. Section 9. Navigating the AI frontier: skills, ethics, and what's next. As AI continues its rapid cosmic expansion, what's next? One crucial aspect is the need for continuous learning. The AI landscape is evolving at an incredible pace. To stay relevant, professionals need to upskill. This doesn't mean everyone needs to become an AI researcher, but a basic understanding of AI principles is vital. Knowing how AI tools can be used in your field, learning to collaborate with AI systems will be key. This brings us to the ethical responsibilities of AI. With great power comes great responsibility, as they say. AI systems are trained on data, which can contain biases. If we're not careful, AI can perpetuate or amplify these biases. This can lead to unfair outcomes in hiring or lending. Transparency and fairness in AI algorithms are crucial. We need to ask, who is responsible when an AI makes a mistake? These are complex questions society must grapple with. Then there's the ongoing debate about future potential, including discussions around artificial superintelligence, or ASI. This is a hypothetical AI that would surpass human intellect. Some see ASI as a potential existential risk. Others view it as a path to solving humanity's biggest problems. These are long-term considerations, but important ones. Don't forget to like, share, and subscribe for more insights on AI and its impact on our future. Powered by generative artificial intelligence. Thanks for watching and see you next time.